in the grammar we are having regular grammar, context-free grammar, and context-sensitive grammar. And the last one is unrestricted grammar. Unrestricted grammar. Right? So we are having now the 4 types: regular, context-free grammar, then context sensitive grammar, then unrestricted grammar. Right. Now, for representing the grammar, we are having some notation. Now, the notation is, if you are having in capital letter as italic capital letter, so A, B, C, D, E, up to some 10 letters, this is called actually non-terminals. Right. So the representation of that first 10 alphabet with the italic capital letter, this is used for representing non-terminal. What do you mean by the non-terminal is, this non-terminal can have a terminals. Non-terminal can have a terminals. Right. Now the terminal is represented by the small letter A, B, C, D, E. Right. So all small letters is called terminals. It's called terminals, and small letter, some operator. So these are all the small letters and some operator, you call it as terminals. So what you mean by the terminal is, here if you are having now that we are deriving, A derives E, E derives E plus E, then this E derives ID. Now the leaves are terminal. So these are all the leaves for the tree. Now you see this one, this leaves ID plus ID. Right. So that is here we are having now, there is no further branch for this one. So this is called terminal. Terminals are, there is no further branch. So the further expansion is not there, right? So this is plus is terminal, ID is terminal. Then, so in the tree, we all leaves are called terminals, right? Then all nodes are non-terminals. This non-terminal can derive to another terminal or non-terminal. So on, this is called non-terminals, right? All capital letters are called non-terminals. The non-terminals are represented by A, B, C, D up to 10 letters maximum, right? The small letter A, B, C, D up to 10 letters is used for terminals. For representing terminals, we are having now using the terminals, right? Terminals can be represented by a small letters or some operators, small letters, right? Then we are having now string of terminals, right? So string of terminals, right? So all are the combined terminals, right? So this is for example, ID plus ID. This is a string of terminals. So the string of terminals is represented by the alphabet last letter W, X, Y, Z. The small letter, right? Small letter with the last 10 alphabet, or last 10 alphabet is used for representing a string. So the W is a string. The string may be any terminals. So W equal to ABC. So this is a string of terminals. So a string is called a string of terminals, right? So these are all terminals. Then sequence of terminals are called a string. The string is represented by the small letter with the end of that alphabet. Z, Y, X, W, and so on. So we are using now, this is for a string of terminals. So this is ID, say Z equal to ID plus ID. So this is string of terminals. So this terminal 1, terminal 2, terminal 3, right? Next one, we are having the capital letter alphabet at the last. X, capital Y, capital Z. This is called as grammar symbol. One grammar symbol. This is X, Y, Z. It's called grammar symbol. This grammar symbol may be either a terminal or a non-terminal or empty. Either a terminal or non-terminal or empty. Then we are representing that one with X. So X may be a non-terminal, or X may be a terminal, or X may be empty. So that is called a grammar symbol. One symbol. The symbol may be a non-terminal, or a terminal, or empty. So that is, now we don't know what it is at the end. So just we have to give you here one grammar symbol. The grammar symbol may be a non-terminal, or the grammar symbol may be a terminal, or the grammar symbol may be empty. So that is represented by the alphabet, end of alphabet with capital letters. This is for grammar symbol. Right? Then we are having string of grammar symbol. String of grammar symbol. String of grammar symbol. What it is actually? Here that this is represented by alpha, beta, gamma. This alpha is string of grammar symbol. Alpha derives capital letter X, capital letter Y, capital letter Z. Or alpha derives X1, X2, X3. So this is one grammar symbol. This is another grammar symbol. This is another grammar symbol. So string of grammar symbol. So this may be a non-terminal. This may be a terminal. This may be another non-terminal, or this may be empty. Like we can have now up to that any number of symbol. Right. So that one is, we call it as string of grammar symbol. String of grammar symbol. Right. So these are all the notations. Right. So here we are having the grammar notation. You understand the grammar notation is, here one is a non-terminal. The non-terminal is represented by that capital letter with the starting alphabet of capital letter. Next one is terminal. The terminal is, we are having now the small letter alphabet starting from 1 letter to that up to 10 letter. Then all operators are the terminals. Next one, string of terminals. So we are having a sequence of terminals are there. Then we can represent by the alphabet at the end of that alphabet with small letter Z, Y, X, W, small letter. Then we are having a grammar symbol, one grammar symbol only. A grammar symbol is represented by the alphabet, end of that alphabet with capital letter X, Y, Z, or something, right? So that is called a grammar symbol. Right? So these are the important. And then we are having string of grammar symbol is represented by alpha, beta, comma. String of grammar symbol is represented by alpha, beta, comma. 1 minute, somebody is waiting. I will admit that one. Okay. I will continue. Right. Arun Kumar? Arun Kumar?
Yes, sir. Yes, sir.
Can you understand now?
Yeah, sir.
Everybody is having question about that. Are you, all of you note down it properly? You should have a note and you have to note down that one, right? One by one. What is non-terminal? What is terminal? What is string of terminal? What is a grammar symbol? A string of grammar symbol. Clear? Arun Kumar, any disturbance in the background sound?
No, sir. It's clear, sir. Your audio.
Clear, right? Okay. Okay, shall I erase it now? Or otherwise you want to note down, then I will wait another 2 minutes. Clear? Shall I take another screen?
Yes, sir. Yes, sir.
Okay. Right. Now, a regular grammar, right? So we are having the types of grammar. I'm going to give that one. Okay. The types of grammar as right. Here we are having now string of grammar symbol. Okay. Now the types of grammar, right? I told you that one regular grammar. First one, regular grammar. Right? So sorry. Regular grammar. Right. This is we are having now a non-terminal derives a terminal, or otherwise a non-terminal derives a terminal followed by another non-terminal. We are having the production rules of the form a non-terminal derives, the arrow mark is represented as derives, right? Arrow mark is represented as derives. A non-terminal derives another terminal, or a non-terminal derives a terminal followed by terminal. Any production rule, if in that form, now you consider it as a regular grammar. I consider it as a regular grammar. Now you see this one here, A derives. Here we are having now that one as A comma B, or otherwise that A terminal, right? So only the production rule of the form, then we have to consider it is a regular grammar. The grammar, this is actually type 0 grammar. The regular grammar. The next grammar is context free grammar. Right? So that is, we call it as CFG. All programming language, we are having a context free grammar. The grammar with the production rule of the form, a non-terminal derives string of grammar symbol. A non-terminal derives alba. A non-terminal derives alba. That is string of grammar symbol. Alba. Otherwise, we can have no A derives beta. Like we can have no. Alba is string of grammar symbol. So here x1, x2, x3. Right? For a simple example, we are having E derives E plus T. E plus E. Here, this is of the form A derives. We are having now, this is alba. These are all alba. So this alba is, this is x1, this is x2, this is x3. A string of grammar symbol. The first symbol is E, second symbol is a terminal, then third symbol is a non-terminal. So non-terminal, terminal, non-terminal. So this is, we are having now E, this is plus, this is E. Right? So that is we are having now of the form, right? So a non-terminal derives a string of grammar symbol, you call it as context free grammar. Right? So that one is here. We are having now E derives E plus E, E derives E star E. Right? Yesterday I introduced that grammar rules, right? So these are all grammar rule for assignment statement, right? So here we are having up before that A derives ID equal to E. A derives ID equal to E. This is 1, this is 2, then this is 3, this is 4, and then we are having some other problem. So we are having 5 that IE equal to constant, right? Then we are having now E equal to E minus E also, right? So these are all the, so E derives E minus, right? So here you see this one, here all production rule, the left hand sides are a non-terminal. Left hand sides are a non-terminal, and the right hand side we are having now a grammar symbol, right? We are having now here, this is called x1, x2, x3. Similarly here x1, x2, x3. So here this is x1 only, that is a terminal, right? So here we are having a terminal. So all production rule of the form A derives alpha. So this is called context free grammar. Suppose they may ask 2 marks question. Define context free grammar, give an example. Right? So now you have to represent that one. A context free grammar is having the production rule of the form A derives alpha. Here A is a non-terminal, then alpha is a string of grammar symbol. The example is we are having one assignment statement. We are having these are the set of production rule. So this is one context free grammar. Right? Next one is context sensitive grammar. Clear? Arun Kumar?
Yes, sir.
Right. This is a context free grammar. This is type 1. Right. So this is we are having now type 0. This is we are having now type 1. Next one, we are having now context sensitive grammar. Right. Now, this next production rule. Next production, next grammar is context sensitive grammar. Context sensitive grammar. Right. Context sensitive grammar. This is we are having now the production rule of the form. The left hand side also we are having a string of grammar symbol, and right hand side is also another string of grammar symbol. So the left hand side we are having a string of grammar symbol. The right hand side also we are having a string of grammar symbol. But the restriction is the length of the alpha should be less than length of beta. Length of the alpha should be less than length of the beta. Length is actually we are having the number of symbols within that one, right? So here we are having now a derives a is equal to a derives something here. We are having now c d a. So here one string of grammar symbol, here another string of grammar symbol. But the restriction is here we are having two elements. Length is 2, here the length is 3, right? That is called context sensitive grammar. So here we see this one. Here if you are having the last, we are having A, then only this A is replaced by CD. So that is context sensitive. So that is called context sensitive grammar, right? So that is represented by alpha derives beta. A string of grammar symbol derives another string of grammar symbol. The restriction is the length of the left hand side should be less than length of the right hand side. Then it is called context sensitive grammar, right? So that is type 2 grammar. Next one, unrestricted grammar. Unrestricted grammar. Okay. The unrestricted grammar, here, whatever here, alpha, there is beta, there is no restriction. Right. Now, you can see that one, all regular grammar, we can call it as context free grammar. Right. Context free grammar. All regular grammar called context free grammar, right? Here you see this one. Here the restriction is here regular grammar is we are having the restriction is a derives a b or a derives a. Right? The context free grammar is a derives alpha. Here this also alpha. But all context free grammar is not regular grammar. All context free grammar is not regular grammar. So the all regular grammar, right? So is a subset of context free grammar. Right? CFG. It's not G, CFG. Context free grammar. Right? The context free grammar is the all regular grammar, we can call it as context free grammar. But all context free grammar is not a regular grammar. Because the context free grammar is we can have now any length. A derives alpha, the alpha is any length. So A derives A, then B, C, D. So we are having that length. But here we are having only the restriction is a terminal followed by a non-terminal or a terminal only. A production rule of the form, then we are calling it as regular grammar. right? So regular grammar can call it as context free grammar, but all context free grammar cannot be called as regular grammar. Similarly, then context sensitive grammar is all context free grammar. Regular grammar we can call it as context free grammar, but all context sensitive grammar is not context free and regular. Next one, the last one is unrestricted grammar. So all grammar is unrestricted grammar included. Right? So this is actually we are having now Chomsky hierarchy. They will ask that one. Draw a Chomsky hierarchy, right? So you have to draw that inner circle as regular grammar. The next outer circle is context free grammar. Then next outer is context sensitive grammar. The next outer is unrestricted grammar. Right? So this diagram is called Chomsky hierarchy of grammar. 2 marks question. In 2 mark question they used to ask that question, Chomsky hierarchy of grammar. Chomsky hierarchy, right? Chomsky hierarchy of grammar, right? So we are having 4 types of grammar. In that 4 types, first one is regular grammar, the context free grammar, context sensitive grammar, and unrestricted grammar. You have to draw the circle with that inner circle is regular grammar, context free grammar, context sensitive grammar, unrestricted grammar. This is called Chomsky hierarchy of grammar. Chomsky hierarchy of a grammar, right? Clear? Arun
Sir, if,
Kumar?
sir, if the regular grammar circle is inside the context-free grammar circle, then regular grammar should be a subset of context-free grammar, right?
ஆமா like regular so subset regular grammar context free 1 minute actually all regular grammar is called context free grammar, correct? Then the regular grammar is a subset of context free grammar, correct?
Yeah, but you have written opposite, no, sir. You have written context-free grammar is a subset of regular grammar.
Where
There, CFGCRG.
I put the circle, no, the all regular grammar included in the context free grammar. So context free grammar is the outer circle. Within that one, a part is regular grammar. Can you see? Understand now? Please ask question. If you are having doubts, you can clarify. What you think about that one? You tell me.
No, sir, you have written CFGCRG and C means subset of. So you have written CFG is a
Let's see.
subset of.
This is like that. Oh, this is actually in the diagram, right? This one, right?
Yeah.
And the green letter. So this is wrong, right? Like how it is. This is all regular grammar is included within the context free grammar.
Sir, just change the symbol. That's it.
You should
Like
reverse
that
the
you have
C,
to
sir.
put this one.
Yes, sir, that's it. I mean, like you can
Oh,
write RG front and CFG next.
okay. So this is RG is subset of the context free grammar, right?
Yes, sir.
Correct. Okay. We have to draw this diagram, right? Context free grammar with this symbol and context sensitive grammar with symbol, right? Correct?
Yes, sir.
Correct. This and this diagram, right? Okay. This circle diagram is correct now.
Yes, sir.
So I missed the symbol. Okay. Sorry. Okay. This is correct now. Good. Very good. This is correct, right?
Yeah, it's fine now, sir.
Okay. The set symbol I missed. Okay. Okay. Is there any other doubts, please? Now the doubt is open to all. If you are having doubts, then you can unmute yourself and you can ask question. Then we will continue by the next topic. Please, any one of you. Rangarajan,
Yes, sir.
it's okay now?
Yeah. Yeah.
Chandana,
Yes, sir.
Anybody else? You are having the question? Otherwise, I will continue the next topic. Okay. Now I will continue now, right? So if you are having the doubts on Monday class also, you can ask, no issues, right? Okay. We will continue. Okay. So these are all the grammars, right? Now we'll go for using grammar. Now we are deriving a string, right? So that is called derivation.
Sir, Arun is asking to repeat.
Who?
Arun Kumar.
Aruna?
Yes, sir.
Arun Kumar. Arun Kumar. Okay, okay. You want to repeat everything or this grammar only?
We are just grammar, sir.
Yeah. Okay. Sure. Right. Now you see this one, we are having now the first grammar is the regular grammar, right? So that regular grammar, right? The regular grammar is having a grammar with the production rule with a non-terminal derives a terminal or a non-terminal derives a terminal followed by non-terminal. All production rules should be in that form. Then the grammar is called regular grammar, right? The grammar is called regular grammar. The next grammar is context sensitive, context free grammar. This is all programming language is having context free grammar. The grammar is of the form A derives alba. Alba is a string of grammar symbol. There is no restriction on the length. So any length we can go for alba. So the alba is we can string of grammar symbol, string of grammar symbol, string of grammar symbol, and so on. Then we can go for n number of symbol, right? The n number of symbol we can have now as a grammar symbol. So this is called string of grammar symbol alba. All production rule of the form a non-terminal derives a string of grammar symbol, right? So if you are having production rule of this form, then the grammar is called context-free grammar, right? Here you see this one, the regular grammar can also be called context-free grammar. So all are like that. A derives alba, one string of grammar symbol, but we are having the limited number. Here there is no restriction at all the number. So all regular grammar is context-free grammar. Then all context-free grammar is not a regular grammar. Next one, context-sensitive grammar. Context-sensitive grammar is of the form alba derives beta. The restriction is the length of the alba should be less than length of beta. Length of beta less than or equal to length of beta. Not less than or equal to length of the beta, right? Then unrestricted grammar, right? So unrestricted URG, unrestricted grammar is alba derives beta. Here there is no restriction on both ends. So this may be a long length than that one, right? So there is no restriction. That is called unrestricted grammar. Clear, Arun? Arun? Arun, is it audible?
Sir,
Sir,
yes,
is
sir. My mic have some problems, sir.
Okay, no issues. Okay, I will continue that next topic. Right. Now, the derivation. Derivation is we are derive a grammar, right? So here, now we'll consider we are having a grammar. I'll write another grammar as S derives. Right. We are having now S derives open bracket T close bracket and T derives yes, T derives yes. Now T derives yes or T derives yes. Now here we are having S derives no. Now you consider this is a grammar. Right. So here we are having now. This is actually S derives open bracket T close bracket and S derives A, right? Then we are having now T derives T comma S, right? Then R S. Right. Now, what do you mean by that one as here using this grammar is T derives yes or T derives yes, right? Not yes. Right. So that one is here. Right. It is a grammar one by one. You will write. Sorry. 1, 2, 3, 4. Right. So now is a grammar, right? So by this grammar, what we can derive now that one as S derives open bracket T close bracket. Then the T derives T comma S. Right. Then we are having now that the T derives S, the S derives A, and this S derives A. At last, what we are getting now the string is open bracket A, comma A, close bracket. Right? Using this tree, we are generating the string is open bracket A, comma E. Right? So this grammar is actually is used for we are having with comma and we are having that some symbol A is separated by comma, right? So this is a open bracket and equal number of whatever that how many number of open bracket, the same number of close bracket, and it is separated by comma. So this is actually the grammar is generated by the string is generated by this grammar. So this grammar, this is one string. Then another string is here S derives open bracket T close bracket. S derives T derives S. Then once again the S derives A. Or otherwise we can have now T derives open bracket T close bracket and T derives T comma S, right? Then this T derives S and S derives open bracket E A T close bracket. Now we are having now the T derives T comma S, right? So the D derives S and this S derives A. This is derives A, this is derives A, right? Now this is derives A. So what string is generating now by this grammar is open bracket A, comma A, close bracket. Then we are having now comma A, close bracket. So we are having now the how many number of left open bracket, the same number of right close bracket, right? So how many number of open bracket equal to equal number of close bracket, and also we are having that symbol A separated by comma. A separated by comma. So this is actually the string can be generated by this grammar. Right? Now you see this one here. This is actually we are calling it as deriving a string. Using a grammar, we can derive a string. The restriction is you have to start with the start symbol. So in that grammar, one symbol is a start symbol. Unless otherwise stated, the first two production rule left hand side non-terminal is the start symbol. So always you have to start with the start symbol. So yes, right? So yes is the start symbol here, right? So you have to start with the start symbol and then you can derive that any production rule we can use and we can derive any string. So that is called context free grammar, right? Context free grammar. So the restriction is first you have to start with the start symbol and then we can use any production rule in any order. We generate a string. That is called derivation. We are generating a string is derivation, right? Actually we are deriving a string from the grammar is called derivation. Now a given string you are formulating the tree is called parsing, the reverse process. So forward process is derivation, reverse process is parsing, right? So that one is here. Okay, I will draft one more things. file new. Right. Now, right. Please see that one. Right. Now you consider the same grammar. S star is open bracket T close bracket. Then S star is A. T star is T comma S. Or T star is S. Right. Now this is a grammar. Now I want to generate the strings as open bracket A comma A close bracket comma A. Right. So I want to generate this string. This is a string W, right? So we are having string of terminal. The W is string of terminals. So this is we are having now, right? Now I want to generate the string, right? Then how do you generate the string using the grammar? 1, 2, 3, 4 production rules are there. This is called production rules, right? Now here we want to have that open bracket. For generating that open bracket, here it is, right? So first you have to use that STRI's first production rule we are using now. So we are generating open bracket T close bracket, right? So this is using that by STRI's open bracket T close bracket. Next we are having now the another open bracket here, right? Open bracket. So for generating that one, what we need is we are having the this also, right? So for that we need to have the T derives. We are using now T comma S. Now we are using the by the rule is T. We are using T derives T comma S for this T, right? So that is for this T we are using now T comma S, right? Now this is open. Now you want to generate this one. So this one we want to generate. For generating this one, we are having T. Here we are having for generating this one, we want to have that one. We are going to use that one as open bracket and close bracket at the end. So you once again, then you have to use yes. So yes derives open bracket, yes, comma, yes. So we are using the production rule 4. By T derives yes. For the T, we are having yes. Then next we are having now yes derives, right? This yes we are having now. Here what we are having now? This one, A comma A, we want to generate. So you have to use S derives open bracket T close bracket. S derives open bracket T close bracket, comma, here yes. Right? Now we are using the production rule as S derives open bracket T close bracket in that end, right? So here we are using now the production rule. For this, yes, we are using the production rule. We are generating. Now what we need is the A comma A you want to generate, right? So what we need is we have to derive the T is as T comma S. T derives T comma S. All others are as it is. So we are using the production rule as T derives T comma S. Right? Now in the T, what we want to have that one A. This A we want. So now you have to use T derives open bracket yes, comma, yes, yes. Then we are having now yes, right? Now this yes is there. We want to generate this A. Now we have to use production rule 2. So here yes derives open bracket, this yes derives A. At a time you use one production rule. This is yes, this is A, right? Now here we are having by production rule T derives yes. Here we are using the production rule yes, yes derives A. Next we are having this is yes is there. In that place you want to generate A. In that place you want to generate this A, right? So that one we are replacing that one with yes derives open bracket A comma A close bracket comma yes, right? This is we are using now by yes derives A. We are using the production rule, S arrives A. Next, we are having now the last derivation is open bracket, A, comma, A, close bracket, comma, A, close bracket. So we are using now by the production rule, S arrives A. Right? So this is actually we call it as leftmost derivation. Leftmost derivation. Right? So we are having now this is called LMD, leftmost derivation. Why it is leftmost derivation? For all time, we are replacing the leftmost non-terminal. So I'll show that one. This is the leftmost non-terminal, we are expanding. Here, this is the leftmost non-terminal, we are expanding. Right? Here, the leftmost non-terminal is this one, we are expanding. Here, we are having now the leftmost non-terminal, we are replacing. Right? Here, we are having now the next one, we are having the leftmost non-terminal here, we are replacing. Right? Next, we are having now this is the leftmost non-terminal, we are replacing. Next, we are having that these are all the terminals. Here, this is the leftmost non-terminal is S. So S is replacing now. Right? Next, we are having now this S is replaced. So only the non-terminal is S, we are replacing now. So this is called leftmost derivation, right? The rightmost derivation is you have to consider the rightmost symbol derive first, right? So that we'll see the next class. Now we are having the time is 11:40, right? So just you have to put attendance in chat box and you can leave now. Then we are having the class 2:20. Right? We will continue the class at 2:20, 2:20 to 3:10, right? Is there any doubt here?
No, sir.
Right? So we then by next class we will put another rightmost derivation and also we will put another grammar for that leftmost and rightmost derivation by next class. Right? Okay? Right? We can put attendance in the chat box and you can leave now. Then we will continue at 2:20.